Hello and welcome to the first in a series of webinars from Cimteq on the topic of increasing profitability within smart cable factories. Today's webinar is called Industry 4.0 and the Smart Cable Factory. What is Industry 4.0 and is now a good time to invest in factory technology? I'm Ken Jones and I'm your host for today. I'm the Digital Marketing Manager for Cimteq, and today's webinar is presented by Ali Shehab, the President of Cimteq. To give you an introduction to Ali, if you don't already know him, in 1998, Ali established Cimteq to develop Cable Builder and Cable MES, which are world-class software packages for the design and manufacture of cables. Ali is an advocate of smart tools for cable manufacturing. He's a regular contributor to industry periodicals, conferences and blogs, as well as speeches at industrial forums. And just before I hand you over to Ali, there is a chat box which you should see on the right-hand side of your screens. If you have any questions about the topics covered, please do feel free to use the chat box. We want the webinar to be as interactive as possible and answer any questions you may have. If your answer requires a detailed answer, we'd be more than happy to continue the conversation after the webinar. So without further ado, I will now hand you over to Ali Shehab from Cimteq, where he will be talking about Industry 4.0 and the Smart Cable Factory. Thank you, Ali.
Hello, my name is Ali Shehab, and thank you for the introduction, Ken. Very nice of you to say nice words about me. Okay, so let me give you a little introduction about Cimteq, the company I started, and is what it does now. So we are dedicated to the cable industry, to software in the cable industry. Currently, we have two products: Cable Builder for the design and design of the cable, calculation of production parameters, etc., costing, quotations, and we've got Cable MES, which is aimed at the shop floor. It is about the manufacturing of the cables from beginning to end, from your raw materials coming in to goods shipped to the customer. They're both proven solutions, and we are very proud of them, and we're proud of our user base too. Okay. So that's a little bit in an introduction about us. Now, I did a presentation similar to this maybe a year ago, and we were then talking about Industry 4.0, and I call it the legend of Industry 4.0, where you have the Wikipedia calls this cyber physical systems. Now, nobody really knows what cyber physical systems are. But it sounds something terrible that comes and eats people at night, or you have the tech companies that portray Industry 4.0 as the savior and it's the unicorn of all things, and they just want us to pack our factories with technology. But the reality is somewhere in between. And I call these guys a technical extremists, really. Now, that's then. Now, things have changed since then. And then reality has struck, really. So the reality of Industry 4.0 really is to achieve business objectives at the quickest possible way, at the lowest possible cost and the highest possible quality. That is really what we were trying to do with Industry 4.0. Okay, so that is said, let's look at what has been achieved over the years, not necessarily in the last year, but in the last few years, where Industry 4.0 technologies have been used. Mainly, we'll talk about that later, MES and digital twinning, etc. Now, what it's done to factories is in the area of capacity, production capacity. It has revolutionize that, because by installing an MES system, for example, you're able to look at your production and identify bottlenecks in your factory. Now, as a lot of people will know, by solving the bottleneck issue, so removing those bottlenecks from your factories, the products will go through much quicker. And it is a factory you never knew existed. It's like using extra capacity, which you never knew existed. And with the use of MES, you can see where work in progress is backing up. It can identify bottlenecks, resolve them, and monitor the progress of that resolution too. Material savings. This is, again, a typical example from one of our customers, in fact, using our MES and our cable design system, Cable Builder. The two are linked together. So information are passed from the production lines about radial thickness, I think, in this case, or diameter. And in the background, we have SPC analysis engine going on. When that is finished its job, it starts recommending things to the design engineer of how to improve the design, the material utilization on the design. So it says, come on, you are giving away too much material. Consider enforcing running process closer to the target, because this factory has been set up for many years. Tolerances have been changed, but processes have been improved, and the process in this case is much more capable than the design engineers were designing the cables for. So they saved a lot of money. This is a jacketing line. They saved a lot of money on materials, so reduce the material usage, improve the profitability of the factory, etc. And next, I want to come to efficiency improvements. So decreasing of downtime using downtime analysis, increasing machine speed using OEE and various losses analysis, etc. And as linked again to capacity, improving lead times, because we're running faster, you are producing quicker and improving lead time. And finally, quality improvements. And all this we have seen. This is in the last few years have come out of these technologies. So quality improvements, mistake prevention. I can give you an example where an operator is busy making a fiber cable. He puts in a reel which contains fiber into a cable, and then this particular machine is connected to MES, and suddenly the machine starts alarming and stops him using that fiber because it's the wrong fiber. So he scanned in the wrong fiber to use on that particular product, and that one incident has saved our company over $50,000 of scrapped cable. Not to say the embarrassment of shipping something that is wrong to the customer. So these technologies, although they are not cheap, they will pay for their cost very quickly, indeed, in all these improvements. And the savings that you can make on various. I mean, also talking about quality is the traceability, a strong traceability, and the cost of traceability and the quality of traceability improves when you're using these technologies, particularly MES. Okay, so we talked about what can be achieved with Industry 4.0 and smart methodology, and I want you to remember something. Remember that message that is coming from the machine, effectively, to the design engineer to tell them what to do. Okay, so I've seen a lot of pictures on the web, etc., saying, okay, what is Industry 4.0? It's the same as Internet of Things. It's the same as smart factory. Well, no, it's wrong. It's not. Also, there is a smart factory, includes Industry 4.0, Internet of Things, and MES. Again, not quite. Close, but not quite. But to actually understand Industry 4.0, we need to go a step back, which is to Industry 3.0. These are in the days where lean was a big thing, and lean was a methodology that we employed in our cable factories. And then we had technology like automation or PLCs, SCADA, etc. And we had robotics in some factories, which is great. So Industry 3.0 consisted of two things: the technology, which is the automation and robotics, etc., and a methodology, which is lean. And everybody understood lean and worked with it quite well. So to understand Industry 4.0, it is the same thing. So we've got the technologies like Internet of Things, and incidentally, when it's used with in industry, it is now called Industrial Internet of Things. Then you got cloud computing, you got MES, and you've got many other technologies, which are the Industry 4.0 technologies. But the methodology is smart, and we will cover that in a second. It's smart factory. And if you think about smart now in the modern context, it's like mobile phones, smartphones, smart cars. Yeah, if you have a Tesla, it's a smart car. It updates itself. It diagnoses itself, etc. So we'll look at smart in a bit. Okay, so let's look at some of the technologies in Industry 4.0. Cloud computing, a lot of things are happening on the cloud, quicker, much more global. With cloud computing, you also have to have security, cybersecurity. Robotics is again part of Industry 4.0. Visual and augmented reality. Only this morning I was reading about one of the cable manufacturers using these. It's not so straightforward to use them in the cable factory itself, but it's something which we probably want to consider using or utilizing for your customers and your suppliers too. I want in cooperation with them. The Internet of Things is again is part of Industry 4.0. Digital twinning is where you simulate the product in the factory. The construction of the product, simulate the construction of the product, to cost it, to test, to calculate certain parameters of the product, and also calculate how it's going to behave on the shop floor. So you're creating a digital twin of the physical product and its manufacturing. For those of you who use Cable Builder or Cable Design System, that is a digital twinning engine. Big data, again, it's increasingly being used to analyze and make decisions, and it's used in artificial intelligence. And if you'd like, I will talk about artificial intelligence, which should actually be another prong on the Industry 4.0 wheel. 3D printing is part of it. I mean, we can't 3D print cables just yet that work, but if you look at our website, we have been 3D printing models of cables. So when you design them in Cable Builder, you can 3D print them in completely plastic, of course, for presentations and for visualization. simple cables, not so useful, but complex umbilical cables, that is used quite a lot in a lot of cable companies around the world, the 3D printed, and they are used as a discussion point with the customer. Okay, so digitization of factories, that's another name for what is going on right now. Again, digitization of factory needs a strategy and needs a methodology. Otherwise, it's just an expensive hobby. So, for example, if you are using lean, don't worry too much about smart. If you're using lean, use Industry 4.0 technologies to help lean manufacturing, to accelerate lean manufacturing, to help you solve the problems which are the essence of problem resolution is the essence of lean. So yeah, don't get hung up on smart bit. Use the methodology that works for you. Okay, we used to talk about the integrated factory, and that helped a lot in the 90s, early 2000s, the 2000s in fact. So an integrated factory has many systems shown in a pyramid. So you start your design in CAD, it goes to ERP. Then MES and planning gets its data from ERP, and eventually the data flows down the pyramid to the PLCs, which then send them to the machine sensor and detects machine sensors and all that. And data doesn't really flow in multiple directions. It goes from top to bottom. And sometimes it goes from bottom to top, but it doesn't go right all the way to the top. So that's an integrated factory. In reality, what happens? Somebody designs a cable. They send a quotation to the customer. The customer then orders the product, the cable, that is done through an ERP system. When you design the cable, the bills of materials and routing also go to the ERP system or held in the ERP system. Materials are then ordered to replenish warehouse into the ERP system, from the ERP system. When it's ready for production, the ERP systems will then send production orders to the shop floor with manufacturing instructions. They are then sent to the operators, which are then sent to the PLCs, if you're lucky, if you have that level of automation, and machines can be controlled. Usually, recipes are held in SCADA and sent to production lines if production lines can accept them, or you have that infrastructure. You also have other devices connected to the PLC, like a length measurement device here. And once a production order is complete, progress is reported to the SCADA to say it's finished. That is then reported to the ERP system, and the ERP system will then order dispatch to the customer. Okay, so how does that differ to a smart factory? In a smart factory, a lot of these things still happen. But what happens is a smart factory is communicative. So there's communication between people, between machine and people, between people and machine, and between systems and machines and machines and machines. And it's adaptable. So if there is something that needs to change, it can be changed. So the smart factory in its essence can be adapted. Same as your smartphone. It is very adaptable. So you put an app on it and it does something new. And it's also communicative. And it's collaborative. So you are collaborating again with other instruments, other people, other machinery, customer to supplier, etc. So This collaboration is also part of the smart movement, if you like. Calling it smart movement. So what does that mean? That means information now flows in a different way, and information is utilized as soon as it is available. No waiting and delays to use that information. So length information, for example, measured by a length counter, can go directly to ERP and complete orders. It can go directly to a warehouse. Sorry, showing a shipping yard there, but it should be a warehouse, to order material to replenish what is being used for a particular production order, etc. So the same information can be sent to the design through some aggregation to improve the design. So we saw before about material utilization, but efficiency as well. So you can calculate the efficiency of actually running that cable on the machine, calculate OEE, etc. And that is very useful in the design aspect and the costing of the cable. Of course, length is used within the machine itself, under the production operators and production engineers to influence the efficiency of the machine, again by downtime analysis, breakages analysis, etc. And short length alarms. Now, in the past, where you had mechanical counters, etc., it was difficult to detect when a short length occurs. But now, when a short length occurs, it triggers an alarm immediately, so somebody could take action before the cable goes further and further value is added to it. And the length information can go to sales, and they can inform the customer of the progress of that particular order, of where it is. It can be used to order trucks to dispatch a cable on when the length is about to be reached for the final product. So what this is doing here is one piece of information is used in multiple areas of the business, and it's used immediately for its immediate benefit. Now, how does this work in reality? This works by having an intermediate layer, which is what we call the Internet of Things, the Industrial Internet of Things platform. And this, what that does, that collects information from the shop floor, signals like length, like diameter, like any sparks, etc. And they make them available to higher systems in the organization. So they're made available to MES, to ERP, to design departments, to sales, to other machines, etc. So what we say here is we're democratizing information. So everybody in the business, every system in the business has access to that information and can use it in a way that is conducive to its operations. Okay, so can an extruder be smart? Well, yes, because it will have attributes like communication, collaboration, continuous improvement, adaptability. So for example, extruders can now link back to the manufacturers. Data can be gathered on the extruders and sent back to manufacturers to analyze the efficiency of the operation of the extruders. Extruders software can be downloaded to the machines, to the PLCs and to the SCADA to improve the efficiency of those machines, and that can be done by the manufacturers themselves, of course, under control of the of local engineers. So it is an extruder now is adaptable to its environment and the products it's making. Recipe-driven, more and more we see recipe-driven production, so you have consistency of a product across different operators, different shifts, etc. And you have recipe management tools like Cable Builder, for example, which will maintain the recipe to the product design. So there's less mistakes, less quality issues that can arise. So machines can communicate with other machines. And using the Internet of Things platforms, a machine, when it's not producing as quickly as possible, could tell further machines down the line to slow down, hence reducing the amount of quality issues downstream, which which can be unnecessary. An extruder could start warming up, for example, when the time comes to use it to save electricity, rather than having an extruder on all the time, and or having to switch an extruder on to warm it up and wait for it. Just a simple example. Now, what could also be possible, and this is a smart way of using Internet of Things platform, is not just an extruder, any production line could send notification to various people and various functions of the business. So when an extruder, for example, a production line has a lot of work in progress backing up behind it, and its OEE's efficiency has dropped to a certain level, it could alarm to say, I am becoming a bottleneck here. What do you want me to do? And that notification could go to the correct person. Okay, so these smart assets, I mean, we just talked in this case about extruders, but we also talked about other things which are part of the Industry 4.0. There are assets like MES, like digital twinning, like various other assets. This data, the data is a huge asset. So these smart assets are becoming smarter. But smart assets don't make a smart factory, as they say. A smart factory has to be communicative. You have to use the smart asset for communication, adaptability, and collaboration. And strategy is definitely needed. We are at Cimteq have quite a long experience in helping companies with strategies into coming into a smart factory, adapting tools into a smart factory. You're welcome to use this. Now, of course, with any technology, there are threats. So reliance on communication systems, you need security. You really do need good security. And if a piece of information is wrong when an information is used throughout the business, as we saw, can have amplified consequences. So we need to make sure information is correct from the source and correctly used in this scenario too. Okay, so let's just go back to see what has been achieved now in the past 2 or 3 years, really. Capacity improvements in factories. That has been quite a revolution. Factories have doubled their capacity in some cases. I know one factory who thought their bottleneck was the stranding line, and after doing some analysis, eventually found out the bottleneck is actually the armoring line. And by resolving that, they really accelerated the throughput through the factories. They built a new factory almost. Material utilization, where we saw how somebody has saved a lot of money by the system communicating with the design engineer to say, you're doing something not wrong, but out of date. We saw how mistake prevention saved the company a lot of money. Okay, so it's a smart thing to invest in the smart tools, as I say. But is it the right time? Well, contactless remote working has really pushed that forward as well. So you don't need to step into the factory to monitor what's going on. Okay, it is with the current situation, and hopefully that will go away. But what it has done is actually having to remote monitor, having to have alerts rather than going and searching for problems. Problems will come to you. When there is a problem detected, you will get an alert, you get a notification, and then you will have all the information at your fingertips to resolve a lot of these problems remotely. So there is a little, not little, but there is less substantial involvement with the direct physical shop floor at this stage. Everything can be done remotely. And this is what I call electronic self-service as well. So when you get a notification there is an issue, you can very quickly go and historically look at, okay, there's a problem with the extruder, something. You can go backwards and say, well, okay, what was the pressure on the extruder when that problem occurred, etc. If there's a quality issue, you can trace it back to what happened on that machine on that particular day, on that particular batch. It's actually by batch, not by time, when it comes to using this information. And finally here, this is actually something happened recently. One of our customers produces energy cables. Now, the energy market is not so buoyant at the moment, but the communication market is. So they use Cable Builder, our cable design system. And within a couple of months, they were able to switch the product range, or at least switch the design from production of energy cables to communication cables. Of course, there was some investment other than just the design to actually make them. But it's in this day and age when demand is changing rapidly, then you need tools to do that, and using the digital twinning, as I said, which is a Cable Builder, is a good tool, and also use MES. So when it goes to the shop floor, you are monitoring. You're not just telling the operator what to make, you are monitoring what they are making, especially for new products, to make sure what is being produced is correct. There is no material wastage, it is running efficiently, etc. So yes, it is the right time to invest for efficiency improvements, for remote working, and also for the flexibility of switching between designs. Okay. The next question, to buy or to build? Because these Internet of Things platforms are available. There's a lot of software that's available out there. You can build your own MES, if you like, or contract it to a system integrator to build it. It's not a simple task. It is highly complex making MES for cables. And there are many examples of failures in this field, unfortunately, for cable manufacturers who have tried to do it, either taking far too long or the cost spirals out of control. Please, if you're looking for these smart tools, look for pre-built tools. Cimteq, we supply Cable MES and Cable Builder, which are both smart tools, and they provide the quickest return on investment. Okay, smart assets, as I said, smart software, smart machines, a lot of things are becoming smarter, and they are on the market. So really, I ask you to work on your smart strategy, and the next webinars will help you with those as well. And be disruptive, because these technologies are they're not passive. You have to be prepared. And again, go back to the smart factory. The smart factory has to be adaptable. It has to be communicable, and has to be continuously improving. So you will see disruption, but disruption is good in this case, because if you keep doing the same thing, you will get the same results. If you want different things, you have to disrupt the status quo. So yes, please do go ahead and have a strategy and implement that strategy for being smart. Not forgetting, again, your existing methodologies. If you're using Lean, include that as part of the smart factory. And thank you for that. Okay. I very much appreciate you listening to me. And we go into questions, and I pass it now to Ken.
Thank you very much, Ali, for that presentation. I'd like to open up the webinar to questions now. So please use the chat box to put a question to Ali. I can see that we've got one question come in already. I'll read that out in a second. Yeah, we're here for the next 10 minutes or so. So now's your chance to put a question to Ali on any of the topics he's raised. Okay, so we do have a question which has come in, so I'll read this one out to you, Ali. Mm-hmm. Is there any fully operating smart factories? If yes, where and how long have they been operating?
Okay, what is a smart factory? A smart factory that is collaborative, adaptable, communicative, and has the technologies that I have described. Yes. Yes, I can think of some factories. I use our tools, which are smart tools, the digital twinning, Internet of Things, etc. And 2 years, 3 years now, maybe there are in various parts of the industry. Some are in energy cables. Fiber cables benefits a lot from that with the traceability. But also we have seen power cables also adapt these tools. And in the case of power cables, it is the efficiency, it is the capacity improvements where they are getting those tools. These technologies are by no means new. I have been working on these smart technologies in the 90s, and they were yielding results then. But what has changed now is the interconnectivity between those tools, and that has given a huge improvement, as we described earlier. But yeah, 2 or 3 years, I think, where you have the full factories have been using those to a full extent, if you like, of connectivity of these systems and getting those benefits.
Okay, thank you, Ali. We've got another question coming in about MES this time. Mm-hmm. So does your MES, a cable MES, require you to make changes to the PLC programs of the machine, or to make additions to the PLC code of the machine?
We need to communicate to the PLC. Generally, the minimum information you need from the PLC is the length that has been produced, and from that, no, the length, sorry, the speed. And the length, obviously. So from the speed of the machine, you can tell the length. You can also tell if the machine is started or stopped. So there's a lot of information. If there is a quality problem, you can log it against the length that was produced. So you don't need a lot of signals from the PLC. Generally, what we find is everything is there in the PLC in tags. And so long as we can talk to it, and with our industrial Internet of Things, which is from Wonderware, we can talk to almost any PLC and any device. So no, there shouldn't be a need to change any programming in a PLC. We just simply read what is being logged in the PLC.
Okay, thank you, Ali. We've got another question now about manual operations. So, can a manufacturer completely remove or keep manual operations on the factory shop floor? If that is possible, what will it take for such a factory to be operational?
I'm not quite sure what you mean by manual operation. For example, packaging. It could be a manual operation. So what happens when you are using MES? We allow for these manual operations to occur, and they can be planned, they can be scheduled, or they can be ad hoc. And they are reported as a part of the production order. So for example, a production order may say stop here and do an offline test. And the MES will instruct the operator to stop when they need to stop, do the online test, and the result then is reported back to MES, which is then logged against that length, that production order, and then the process carries on to the next process. I hope I answered your question. If not, please ask it again.
Thanks, Ali. I'm just going to leave it one more minute for any more outstanding questions. Like I said, we're here for the next 5 or 10 minutes, so now is your chance to put a question to Ali. And like I said, if a question requires a detailed answer, we've got no problem taking the conversation offline after the webinar. So please feel free to ask any questions.
Okay, let me just say a final thing. So what I've done today is really just introduce a high level of smartification, digitization, really. And the next two webinars, we dig a little bit deeper, but I will pass that on to Ken.
Okay, thanks, Ali.
Tell you about them.
We do have one more question, Ali.
Oh, sure. Sorry, I'll go back now.
That's okay. Do Cimteq offer an audit to see if their product is suitable in older plants?
Yeah, absolutely. That's one of the first things we do. We set up a workshop, which is called what we call a scoping workshop. So we not just look at what you've got on the suitability, but you would get a full report of what you maybe need to change to implement our tools and implement more further smart tools, and we'll come up with a schedule as well and a costed with you, and we do that in conjunction with our partner Wonderware. So yeah, absolutely, we will do that job for you, with you, in fact. to understand what, in fact, one of my colleagues is doing something very similar. It's a bit of a challenge with the COVID situations because you can't visit factories. It would be nice to go to every factory, open the cabinet, and see what PLCs you've got. But I'm sure with a little survey that can be achieved quite easily. But yes.
Okay, we got another question about PLCs. What about machines without PLCs to be integrated for the MES?
Okay. Okay, so some machines may not, and I answered the question earlier, but the manual. So all the reporting from them is manual. All instructions to them are manual, so they probably will not need a PLC. Now, where you have machines which we want to gather information from them, we recommend installing a small PLC which will only read the speed of the machine. So long as we can gather the speed of the machine, and you may not need a PLC, you just need a sensor, and so long as it can be connected to a bus, then we can read that. And from that one signal, we can do quite a lot. So we can, as I said, we can detect the progress of the order, we can detect the whether it's stopped or started, the speed of the machine, if it's running fast or running slow, and that's enough. So you don't need to have every machine in the factory with the PLC. No, not at all. Of course, the more there are, the more information we can gather, and the better it is. But you don't necessarily need.
Okay, we have a follow-up question to the manual operations on the shop floor. Okay. So the questioner was saying, I was referring to labor issues, and when they happen, operations on the cable machine shop completely stops. Minimization of hands-on functions on the floor could be beneficial.
Okay, so a cabling machine that stops, for example. So what will happen is an alarm is raised, depending on what is the issue. So the Internet of Things platform could detect what the issue could be by communicating with various parameters on your PLC, for example, and then call out maintenance. Automatically, so you can send a notification to maintenance to say this machine has stopped or slowed down. This is maybe the reason. So come and have a look at it. And operators can also interact with that. So if a machine stops and it doesn't know why it stopped, the operator can say it is stopped because of run out of material. So later you can analyze that these machines are running out of material all the time. What can we do to the supply chain to make sure they don't run out of material? Again, I hope I answered that question.
Okay, we've got another question on MES.
Sure.
Is your MES able to schedule the forklifts?
It is not able to schedule the forklifts, but what the Internet of Things platform will do, if an order is coming to the end of its to its end, it could send a signal, it could send a notification to the forklift driver to say, you are needed at this point, at this time. But it will not plan the forklifts themselves.
Okay, thank you, Ali. That's all the questions we have today. Thank you, everybody, for submitting their questions. We just got a few words to wrap up the webinar today. We'd like to finish by thanking you all for joining us today. We hope you enjoyed today's webinar. If you did, we have a second webinar in the series tomorrow at 10 a.m. UK time, presented by Yufei Du, who is the Business Development Manager for the APAC region for Cimteq, and he will be talking about how to apply smart technology to design and manufacturing processes. You will receive a follow-up email from us in the next day or two following this webinar, which will include a recording of this webinar, so please look out for it. And lastly, we welcome your feedback on this webinar. So can I ask each of you please to leave a comment into the chat box to let us know what you thought about the webinar. That will be really useful information to us. So yeah, if you could please do that before you leave today, that will be much appreciated. And thank you once again for joining us today, and thank you to Ali.
Thank you, Ken. It was nice to talk to you all. One thing which I said I will talk about, and I forgot somehow, which is about artificial intelligence. There is a lot of scope when we're talking about smart and linking systems together. And we saw how in one case, the operator, the design engineer gets notified about a cable that can be improved. There is a lot of scope when it comes to artificial intelligence as well in that field, where the design of the cable can be improved using artificial intelligence tools connected to MES. So once you've made the cable or similar cables, that information can then be gathered using a neural network, using artificial intelligence to improve the design of the product as well. But that's the future. I've not seen a system that does that, apart from what I just showed you earlier about material utilization.
Okay, thank you, Ali. I will leave the webinar open to get the feedback from the registrants today, the attendees, and thank you very much to everybody for joining us today.